What?
LLM are just autocompletes.
You're
Hacking autocomplete.
Today is your lucky day, dear viewer, because I get to tell you a secret. It's all an act. Chat history, system prompts, user prompts, it's not real. It's all
fairy dust. It doesn't exist. It's never landed. It is no matter. It's not on the elemental chart. It's not real.
Allow me to explain as we dive deeper into the world of LLMs. There's a spectrum of opinions about LLMs at the moment, ranging from they're just fancy autocompletes, aka Markov chains, to they're sentient and going to take over any second. The truth is somewhere in the middle, for now. This video is going to be a little bit different than the previous ones. We're not going to be adding on to our existing chat app. Instead, we're just going to be exploring some concepts. Let's talk about how LLM prompts work. Fundamentally, LLMs are just neural networks. And you may be thinking, right, exactly, what are those again? Yeah, about that. We're gonna cover that in a slide, no problem. Actually, we can, thanks to Minhaj Kamal. He's got a great article called Coding a Neural Network from Scratch for Absolute Beginners. Please do go check it out, as it's got a lot of great info, and we're just going to be borrowing one graphic from it. Here's a depiction of a single neuron neural network. It models if there's going to be a storm. The neuron takes an input for if there's dark clouds, and an input for if the temperature has dropped. Notice that the inputs are weighted differently, as dark clouds is a better indicator of a storm than a temperature drop. If the sum of the weighted inputs is greater than 1, then a storm is predicted. For example, if there's only a temperature drop, the sum of the weighted inputs will be less than 1, so no storm. But if the dark clouds and a temperature drop appear, that's greater than 1, so a storm is predicted. And again, make sure to check out Minhaj's GitHub and article for more information. So LLMs are very complex neural nets, but don't worry about the inner workings. We're just going to wave our hands a little bit and gloss over the complicated details for now. I like to think of LLMs as tensors in, tensors out. You may be familiar with the phrase turtles all the way down. It's kind of like that, but instead of turtles, it's tensors all the way down. LLMs only understand and operate on tensors. Mind you, these tensors represent language, but the LLMs don't directly understand language. Keeping in mind the simple neural network example, take an input, maybe we can say hi, then let's apply a model's template. In this case, it might look something like this, where we have special tokens. And then let's convert this template into a tensor input. Then we're going to feed that into our model. Those special tokens you saw, for example start header, are configured during training. They help the model better contextualize the input. Keep in mind that LLM templates and tokenization config can vary between models. After the model has done its calculation, we're going to get a tensor output. It's going to be our original input plus the output from the model. We can then take this output and convert it to the model's template. That might look something like this. And then we can see the response was, hello. It's tensors all the way down. Our toolkit for today is pretty simple. We're going to be using the Hugging Face Transformers library, Python edition, and PyTorch, and Jupyter Notebooks. And that's it. Okay, let's go ahead and dive in. What I want to start with is actually some tools I found to help visualize that tokenization process and also the output sampling. I'll make sure obviously to link these. But yeah, let's take a look. So this right here is a tool to visualize the tick token library. Then again, that's what's going to convert the chat template, the string, into vector points, the tensors. It's got GPT-4o, most of the OpenAI library, and some the open weight ones. So let's start with GPT-4o, although I do want to dive into the open weight ones since that's what we're more interested in. But since GPT-4o and the OpenAI models have the best support in this example. So we can see here, we have got the system filled in. Let's put a user message. How many eggs are in a dozen? And we can see this is how this chat template gets tokenized out. And as we had discussed, the chat template will include special tokens that just help the model better contextualize the input. And these are part of the model's training. So they're going to vary between models, obviously. So we can see here the structure or the template for this is going to be message start, system. So then it knows that it's about to get the system message, separator, and then now we're into the actual system message itself. And you can see this whole string right here is one vector point, one tensor value. This is one, whereas some of these other ones are, like message start contains the pipes and the other characters, right? It doesn't get split out because it's a special one. So you're a helpful assistant, message end, message start, user, how many eggs are in a dozen. And you can see here, again, even though these are strings and there's some formatting, it's in the end, it is just vector points, right? It correlates to vector points. And that's going to get fed into the language model, the neural network. And yeah, so you can see here that words sort of, but not necessarily correlate to tokens. And again, it's just going to depend on the token config. So GPT-4o in this example has the best support, but let's take a look at some others. So it only has Phi2, not Phi3, but if we look on Hugging Face, we can actually dive into Phi3's configs and stuff pretty well. So right now I'm looking at the Phi3 Mini 4K Instruct on Hugging Face. They have the chat template in the model card. So you can see here, pretty standard stuff. System, user, and assistant prompting. And that also, if we take a look at the files, so if we go over here, we can see, it's actually in another tab, Tokenizer config. That's where we can see some of these template tokens correlate to the actual values, right? So you can see here, assistant is going to be this vector point and a text, etc., etc. But again, this example Tokenizer Visualizer does not have Phi3 baked in. It does have Llama 3 though. So now let's dive over to the Llama site. The documentation on Hugging Face for Llama 3 isn't as comprehensive as it is on the actual Meta site. Taking a look at the documentation for Llama 3, we can see beginning of text, end of message, the header to denote whether it's, like system, etc., end of text. So let's see if we can plug in an example chat and see what the tokenizer spits out. So right here, this is going to be our example. Let's pop over and do Llama 3. Let's paste this in here and we can see it's able to parse it out. So this example is going to be helpful AI assistant for travel tips and recommendations. And then the user is going to say, what can you help with? And again, similar to the GPT-4o example, it's able to show you the values here. So beginning of text, header, etc., etc. Again, this is just I think a really helpful visualizer for seeing how these chat templates and chat messages get transformed into vector points, tensors. As we said, these language models are just neural networks, very sophisticated, very powerful neural networks, but fundamentally they just understand tensors. So you are just translating language into tensors so it can do its operations on it. So that's on the input, right? So we're going to take our chat messages, convert it to vector points, feed it into the neural network, and then on the other end of it, we're going to get vectors and tensors back out. So that's where this tool comes in. This, likewise, will be linked in the video. It's a tool to represent and visualize the different output sampling, or I should say sampling parameters. You may have heard these mentioned in passing and just weren't quite sure what does what. So let's take a look. So it has predefined messages. So you're not going to be putting in your own prompts here and seeing what pops out, because that would be computationally expensive, obviously. So let's just stick with this first one and let's try tweaking some parameters. And you can see here, without anything tweaked, it gives us the distribution of possible tokens. So avocados are rich in unsaturated fats, which are necessary for brain function, cognitive development, and the absorption would be the most probable next token. So now if we turn on the temperature parameter, which again, that's what most people start with is temperature. If we dial it way down, right, because we only want to sample the most probable token, we can see now absorption is 99 and change %, whereas some of these other tokens are nearly never going to be selected. And then likewise, if we do temperature way up, now we can see the distribution of probabilities is much more flat, right? So it's not like you're getting absorption and then nothing else. You're getting much more likely to get a lot of these other tokens. So that's temperature. And then what's pretty neat is when you start with some of these other ones, you can actually see the representation of the probabilities right here. So top K, keep the K tokens with the highest probability. So right now it's 50, so that's 50 possibilities down there. And then as we're limiting top K, you can get it down to 1. We'll say, let's do like top 3 or something like that. So you can see how these different variables interact with one another. And we can see here, right, as we're doing some of the other options, you can see how that would interact the output you would get from the language model. So again, this I think is a really great tool, right, when coupled with this. So this is how you get your input, feed it into the language model. You'll get these tensors back out. And then this is how you are able to, once you have those possible outputs, this is the various ways you're able to kind of tweak the dials. So moving on, let's go ahead and dive into some of our own stuff. We are going to start with Flask again, but we'll actually move on to a notebook. But let's go ahead and get a project set up. Okay, so you can see here that all we're doing to get a project set up, just standard what we've been working with, Flask app. So standard directory, we're just actually using Flask. So none of the other dependencies, because we're just going to be using Hugging Face. Let's take a look at each of these. Don't need to care about that. We're just using Flask. Git ignore, standard, Docker compose, just a Python service at this point. So our app, and I'll fire this up in the background actually. All right, so should be running now. Let's queue it up, background, and then we'll take a look at our code. So again, standard stuff from last time. We're just really, all we're trying to do is get our Flask app set up. If we take a look at app and our Hugging Face stuff. So for this first one, we're using Hugging Face Transformers directly. So not Llama C++, not OLlama, not any of that other stuff. We're using Hugging Face Transformers, and we're using PyTorch. So we've got an index route, and all we're doing is calling our helper class, and we're just running that. And I've got arrays in there so we can step through, but let me take that out, and then we can see the output. So as that's running, so when we call .run, we initialize our helper class. And just for simplicity's sake, I have a few models ready to go here. For the fact that we're running CPU inference, again, to sound like a broken record, we're actually going to use Tiny Llama because it's a small, lightweight model. And we only want to, again, explore this. We're not looking for necessarily quality of responses. So we're going to use our Tiny Llama model, and this is going to be cached in our Hugging Face directory, right? So Tiny Llama's there. We're going to use PyTorch Tensors, so that's what that is saying. So we're saying we're using Tiny Llama. We're going to use Hugging Face Transformers to load up our Tiny Llama model. Likewise, we're going to use Transformers to get the proper tokenizer for the model. Because again, models have different chat templates, different tokenization settings. Hugging Face Transformers makes it pretty easy if it's supported to just kind of pass in the model ID, and it knows how to properly set that. We've also got some settings variables here that we'll noodle around with, but for now it's 0.7 on the temperature and up to 512 new tokens. And then lastly, some chat completions to work with. So this was, I believe, in the Hugging Face documentation, but you're a pirate chatbot, and the next message would be hi from the user. So we're going to call run, and what that does is it just allows us to actually go through a couple different types of generations without having to swap out at the index level. The index controller, it's always just calling .run. Let's actually start with the simplest one. So Hugging Face Transformers is not just for language models. It can actually run other types of models like text analysis. So if we do, instead of run, token generate, we're going to do Hugging Face run. This will run a text analysis library on sentiment analysis model against the string "we love you." And again, this is from the Hugging Face documentation. What it should say is that this is positive. So let's take a look. And we can actually see in here, it's going to take a while for inference. It might need to download. Okay. Yeah, it's downloading the model. We'll just give it a second. Okay, it ran. So yeah, you can see here the standard sentiment analysis says it's positive, and it's very, very, very probably positive. So that's, and this is pulled from the Hugging Face documentation, but that's just an example of running just a non-large language model, just a standard sentiment analysis model. So now let's take a look at some other ones. So we're going to start with the Transformers pipeline, which provides some abstractions around wiring things. So it's a little bit higher level than some of the other ones. So let's now, when we do run, let's see what we're going to do. So we're going to set up a text generation pipeline, and this is all done through Hugging Face Transformers. We're going to say that it's text generation. We're going to be using our model and tokenizer. We're going to say that here's the number of tokens we want. Here's the temperature. We're instantiating it here. So you can see we've got our generation args and then also our chat messages. So the idea is it's going to come back with a response to this. So pretty high level again, using the pipeline, you're not really seeing as much of the lower level mechanics. And let's see what the result is. CPU inference, lightning fast. Okay, we're finally there. You can see my CPU was pinned at 99% for a while there. But let's take a look at what it brought back. So You can see generated text, pirate speak, user hi, assistant is responds with I'm a chatbot who always responds in pirate speak, versus some other options, pirate speak, yeah, because we've got our temperature pretty low. You can see this is an example of using the pipelines. Again, still pretty abstracted. So let's take a look actually at the token generate. So LLM run with pipeline versus LLM run, they produce the same result. The only difference is essentially what with the LLM run, we're doing manually what the pipeline would have done. So if we take a look side by side, if we do pipeline here versus LLM run here, expand it a little bit. For LLM run, we're going to take our chat messages list and then get them into that special format. Then we're going to get the tensors out of that, right? And then that's what we're going to run through our model. The outputs is then going to get us our possible tensors. Then we're going to decode it using that tokenizer again. So we go from tensors to options, and then that's our result. And then that would be essentially the same thing you see here. So these two are pretty much the same. Again, the difference is just with the pipeline, it kind of abstracts away these mechanics, whereas here we're doing it by hand. All right, so our last one we're gonna run is gonna be LLM token generate. So this is actually going to be the lowest level. So we're not going to be relying on some of that pre-baked models and stuff. And actually I am going to throw arrays here so we can kind of see all the variables. We're going to be using pseudo step debugging. All right, so now with run, we are going to call this, and we're going to raise so we can get Flask's built-in step debugger to trigger so we can take a look. Okay, so that one actually came back pretty quick. So we are using that, and if we do dump, we can kind of see what variables we're working with. So we can see the input text is I enjoy walking my cute dog, and what that's going to, let's pull it up. Input text, model inputs is again where we take the input and then convert it to tensors. Right, so this is the input, this is the tensors, right, that come out of that. And then that is what we would then feed into the output. Feed into the model to get the output. So we've got these inputs that gets fed into the model, and then we get these possible outputs, right? So you can see it's going to be everything that we started with. We're back. Camera died on me. So you can say that we've got this input that gets this tensor. In this case, we're gonna, let's not dive into attention just yet, but we're going to pay attention to all of these. And you can see the output is going to be the input plus an additional token, right? So if we see 11203, that's going to be dog plus these additional possible tokens. So it's going to be everything's the same plus an additional token. And then if we decode that with our tokenizer, we can see that the decoded possible outputs are, I enjoy walking my cute dog, C. I enjoy walking my cute dogging. I enjoy walking my cute dog, period. Right, I enjoy walking cute dog, being. So C should be 274, dogging, it's me. Then period should be 29889, and then being should be 1641, right? So you can kind of see here that a vector points in, neural net calculation, vector points out, convert that into language. And that's kind of the magic. That's the secret sauce. So this is using Flask. And you can kind of see here that this is pretty nifty, and hopefully you're putting the pieces together. The machine learning and data scientist community has another tool called Jupyter Notebooks. So let's take a look at that. Because if you dive into the machine learning world or, data science world, you're going to run into Jupyter Notebooks. So let's take a peek at what those are and get them set up. Jupyter Notebooks. So now if we take a look at our project, we have, instead of Flask, we've now got a directory for Jupyter. We're also going to run this in Docker, again, performance hit, what have you, but for portability reasons, and so it's easy for all of you to do the same thing. So we are using the PyTorch, Python Jupyter Notebook, or Jupyter Stack, as they call them. And what that's going to look like is, if we go ahead and spin up our stack. So Jupyter Notebooks are a way to have source code and computation in the same file. So it's kind of like a REPL, but it also allows for documentation. So you can probably imagine that if you are a data scientist, why this would be helpful, or a machine learning expert or researcher, right? Because you can have kind of examples and all that just all in one place. Code, computation, documentation in one place. Here's our environment. We're just going to use the stock, put in token, and yeah. So there's different run times. So their Jupyter Notebooks are composed of, again, notebook files. Let's go ahead and create a blank one. So if we just do print I and then run it, this is the result. There's different types of cells, right? So right now this is a code cell. You can put markdown and raw. So if we wanted documentation, we could do like, this is a heading and one super helps if you type right, cool, to more cool, right? And that gets rendered out. So Jupyter Notebooks are really, really neat tools. For myself, as a developer, I'm not using them so much because, again, I'm normally building out applications. But for testing things, for experimenting with things, Jupyter Notebooks are an extremely powerful tool. So let's take our example that we just did in Flask and do it in a notebook instead. Because again, for exploration, using Flask and the debugger is kind of not the right tool, right? We're just trying to take a look at variables and inspect and explore. We're not actually building an application. So let's make a notebook for that. Okay, so if we take a look at the notebook, we can see I took the liberty of doing this ahead of time in the interest of saving time. So we're gonna use install torch, install transformers, right, as we would be doing in our script previously. Import torch, import transformers. You can see we've got the result here, sentiment analysis, and it gets us back positive analysis for we love you. And then we are getting into our example where we're, setting up Hugging Face transformers for language generation. Again, same example. This is the model being loaded here, right? Nothing too fancy there. This is just our setup code. I should note that the cells in the Jupyter Notebook go in order. So that's why you can see here when we import torch and transformers, and right here, I should say, cells after the prior cell. It's done sequentially. So We're doing some setup code here. This is the model being loaded into memory. We're then doing that example, not the pipeline, rather the second example where we're simulating what the pipeline would have done. Yeah, so you can see here, given the messages, which is your pirate robot or chatbot, and then the user saying hi, here is the default template for that. Here's the tokenized input for that. And then we get into the outputs. So given that input, here is what the language model gives us back. So if we take a look, 1.518, 25580, 1.518, 25580. Eventually, if we get down to 2662, 29962, excuse me, we'll see this is where we're getting our new result. So this is the additional token. We'll take a look at this and see the decoded output, right, where it's saying basically all of the possible results are high. Okay, and then if we go on to the last example where it was the lowest level, where I glossed over this set seed, that just allows you to set the random number generator seed so that you get reproducible results. So input text, again, walking my dog, get the inputs for that given string. We get back the 1306 ending in 11203. And then if we run it through the language model, again, likewise, these are the different tokens that we're getting, and this is how that correlates. So you can see, if you're just exploring libraries or kind of running some experiments, for lack of a better word, exploring concepts, Jupyter Notebooks are probably the better approach than using something like Flask, where you're, throwing an error and just kind of stepping through that way. So again, hopefully you're kind of seeing that these language models, they're very powerful, very sophisticated, awesome technology, but they are just models, right? We are just taking inputs, running the neural network calculation, and getting some outputs. And it's just through the training and tokenization that is how we are able to operate on language. So I think for today, that's all. Hopefully you like that little secret, and we will see you on the next one. Thanks so much for watching. We're finally there. You can see I was pegging my CPU.
Pegging my CPU.